So, okay, we will start with the questions of the last chapter because we didn't get time to do questions. Remember, we discussed units, okay, units of different quantities like mass, time, and length. And so let's do this. So remember I talked about how to write in short forms, right? 1 million. Million has 6 zeros. 1 million, million has 6 zeros. So we can write it this way, or I told you this means that 10 is getting multiplied by itself 6 times, right? And I also showed you the parts of how do we write powers, how do we write numbers with powers. So the number which has a power on it itself is called, can be referred to as base or root, and the power on it is written as a superscript. Superscript is a small number that you write on the right upper corner, right? And so when the bases or the roots are same, the powers get added. The powers get added, and so because there are 6 tens, and when we add all the ones, all the powers, we get 10 to the power 6. Okay, we get 10 to the power 6, and this is called a standard form. I'm just doing a recap, right? And also I discussed how do you write very small numbers. 1 millionth, there's a th at the end. This th at the end refers to fraction. Million, as we discussed initially, has 6 zeros, right? So 10 to the power 6, but because it's a fraction, so 1 over 10 over 6, right? 1 over 10 over 6. Now, when we shift this power to the numerator, when we shift it on the upper side of the fraction bar or above the fraction bar, the power, the sign of the power reverses. So if it was positive, it becomes negative. If it is negative, it becomes positive. So since it was positive here, it reversed into negative. So now we have 10 to the power minus 6. Now what does that mean? That just means that you had 1. And I also told you in the last class that whenever we write a number without any decimal, it just means that there is a decimal at the end and then there is 0. This is true in all the cases, but we don't write it all the time, but it's understood, okay? Now, minus 6, meaning that this decimal would jump 6 places backwards. 6 places backwards. The decimal would jump 6 places backwards. This is the first jump, second jump, third, fourth, fifth, sixth, right? And so how many zeros do I get after the decimal? 1, 2, 3, 4, 5. 5 zeros and then 1. So I can write that 10 to the power minus 6 is equal to this, right? Now, once we have revised that, let's do a couple of these questions for practice. So how can we write 1,000? How can we write 1,000? Now, I will unmute the participants whose hands I'll see raised. Okay, you can just tell me orally because the chat is disabled. So I will unmute the participants who have their hands raised. Okay, Furqan Azhar. So you can tell me both ways. You can tell me the normal way as well as in the power form, in the standard form, which is called the standard form. This way is called the standard form. Okay, and there's a name for this as well, which I cannot remember right now, but you can tell me both the ways. Okay, Furqan, tell me, how should I write 1,000? I have unmuted you.
Teacher?
Yes?
10
yes,
to the power of 4.
10 to the power 4? Okay. How many zeros does 1,000 have?
3.
Yes, 3, right? Can you see my screen upright?
Yes.
Okay, okay, good. So, okay, 3 zeros, right? So can I write 1,000 this way? Can I write it this way? Can I write it this way?
Yes.
Okay. So this means what? Can I write it as 1 into 10 to the power what? Now I have 3 zeros, right? I have 3
3.
zeros. So
I
that
think
means 10 is getting multiplied by itself 3 times.
3 times.
Right. So what is another? And now all the 10s have to the power 1, right? Right. So now when I write it in the power form, how will I write? I will add all these powers up, right? 1, 2, 3. So 10 to the power 3, right? Furqan,
Yes.
did you understand?
Yes, I understand.
Okay, good. Okay, now let me ask somebody else. Yeah, I get confused. Okay. Sabiha Azhar. Okay. Sabiha Azhar.
Yes.
Yes. Can you do the next question with me? 1000th. There's TH at the end. So what does that mean?
It means
Yeah, what did I tell you? That when you have TH at the end, what does that mean? This means that this is a, no? Okay, let me ask. I know Atika knows it. Urwa also must be knowing it. Okay, I'll ask from Urwa. Okay, Urwa. Okay,
yes.
Urwa. Yes, please. So tell me, how can I write 1000th with a TH at the end?
0.
No, beta, take me in a sequence. Take me stepwise so that everybody understands. I know that you know the final answer, but let's go it in a sequence. Okay. So tell me.
1 over 1000.
Very good. 1 over 1000. So this is 1000th. Okay, so this is a fraction. Whenever you have th at the end, it means this is a fraction. Okay. So this is equal to, this means that 10 is getting multiplied 3 times, right? Like this. So can I write it? So Urwa, now tell me, what should I write here?
10 minus 3.
No, not minus for now, because I have not shifted its place, right? So it will stay positive. It will stay 10 to the power 3, because all these 10s have power 1, their powers get added, so I get 10 to the power 3, not minus 3 yet. But now when I will shift its place and I will move it above the fraction bar, now it will become what? Tell
10
me.
minus 3.
10 to the power minus 3. So that's how we get 10 to the power minus 3. Now convert this into decimal.
0.0001.
Right. So like we have 1. So yeah, okay. So this will make 3 jumps, right? So because minus 3, and backward because minus. So 1 jump, then second jump. Oh, sorry. And then third jump. So there, this is equal to 0.001. Okay, 0.001. You did not understand, Pidra? See, minus 3, right? So that means 3 means you have to make 3 jumps, and minus means you have to jump backwards, not forwards, because we want to convert this into decimal. That's why, right? Okay. Now 10 million. Okay, Jazakallahu khairan. Yeah, you can keep it to 10 to the power minus 3, but if you want to convert, this is how you convert into decimals. Okay. Rehan Raza. Rehan Raza.
Yes, ma'am.
Yes. Can you do this? 10 million. Let's convert this into the standard form. So how many?
1 0 0.
How many zeros?
6 zeros. 5 zeros.
5 zeros? Are you sure?
Um,
Think again. I just told you million means 6 zeros. Remember? Were you there in
yes.
my last class? Okay, yeah, 1
Uh,
million. Okay, 1 million, 6 zeros.
yes.
So this is 10 million. This is 10
Seven
million,
zero.
7 zeros. So 10, so 1 zero of 10 and then 6 zeros.
Zero, zero.
Right. Okay. So what is the other way of writing this? What is the other way of writing this? So
10 the power. 10 multiplied by 10 6 times.
no, no, no. You will have 1
1
and you
and
will
then you have to multiply that 10 6 times.
6, not 6, 7. Because remember there are 7 zeros.
Yes.
Yeah. So you will write 7 because we want 7 zeros, right? Okay. Another method of cross-checking your answer, if your answer is correct or not, solve this and see if you're getting the same number. Solve it, open it up. I mean, you can convert this back into this, right? So you will write 1 and then 10 to the power 7 means 7 zeros. So just write down 7 zeros. 1, 2, 3, 4, 5, 6, and then 7. So cross check it and see if you're getting the same answer. Okay. Now, another thing that I would like to mention here, though it's not mentioned in your book, but I think it's important to know, because remember, you just said 10 into 10 to the power 6. That was the first answer you gave me. And I said, no, it should be 1 into 10 to the power 7. Now, why was your answer not correct? And why did I ask you to correct it this way? I'm going to explain you that. This way of writing is also called, this is called standard form. It is also called scientific notation. It's also called scientific notation. Now, don't be confused by this. It just means that your number should be in this form. Okay, your number should be in this form, meaning this can be any number between 1 to 9. I mean, it should not be 10. It should not be any double digit number. It should be a single digit number and it cannot be 0. So any digit between 1 and 9. This A can be any digit between 1 and 9. Into 10 to the power x. And x can be anything. Okay, x can be anything. There is no limitation on what type of x you can have, right? For example, you can have this as a scientific notation. Okay, how come? You can have 9 point something because this is still less than 10. Okay, so your number should be between, I mean, it should be greater. I should write it like this. It should be greater than 1, but less than 10. A should be greater than 1, greater than or equal to 1 and less than 10. Okay, so this number has to be, can be equal to 1 or less than 10 into 10 to the power anything. So you cannot write like this because this number cannot be 10. This would be wrong. That's why I told you not to write 10 into 10 to the power 6. Okay? So just you come here and let her sit here. Okay? And we cannot even write like this. Okay? So basically, we cannot get till 10. We cannot get till 10. We have to stay less than 10. This number has to be less than 10. Okay? This is not explained as such, but it is used a lot. Okay, now let's do these questions. 100th. Sidra, do you want to do 100th? Do 100th. Okay, write down 100th. Now it has TH. That means yes, very good. Yes. Okay, good. Okay. Now write it in the standard form. Write it in the standard form. How will you write it? Yes. So first 1 over 10 to the power 2, because there are 2 zeros. Okay. And then you will shift it on above the fraction bar. And so it would become, and it would become 10 to the power minus 2. Okay, good. Now convert this into decimals. Yes. So, yes, and then 2 backward jumps because minus 2. Yeah, here and then like this. So this will be your final answer, 0.01. Yes. Okay. Then 3 million. Okay. Who wants to do 3 million? Irfan? Yes, Irfan? I have unmuted you.
10 raised to the power
3 million. Okay. Yes, tell me. If you know the answer directly, you can give me directly.
10 raised to the power 6.
3 into 10 to the power 6. Okay. 3 into 10 to the power 6 because it's 3 million. Okay. Okay. Next, Zores. Zores. Yes.
3 into 10 to the power of 4.
So let me do this. 3 into 10 to the power 4. Good job. Very good. 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 Okay. Express the following in millimeters. Okay. Let's see who wants to do this. Mariam Afzal. Mariam Afzal. I'm unmuting. Yes, Mariam?
Hello, Miss. Can you hear
Yes.
me?
Yes.
Okay.
Can you do this with me? Do you know how to do this?
We will do 2.7 and then we will multiply it by 1,000 because millimeter is smaller than meter, and then we will go back 4 spaces.
Yeah, because you see, yes, you are correct. We will multiply because millimeters is a smaller unit, and we will multiply by 1,000 because 1,000 millimeters is equal to 1 meter. 1,000 millimeters is equal to 1 meter. So this is how I do it. 1 meter is equal to 1,000 millimeters. So then 2.7 meters would be how much? I will cross multiply. 2.7 multiplied by 1,000 millimeters divided by 1 meter. Okay, so what I get is, yeah, so the decimal place would jump 3 times forward, which would give me 2,700 millimeters.
Yes.
Right? Yes, so this would be equal to 2,700 millimeters. Okay, good job. You want to do the next one? Okay. Romesa Niazi. Romesa Niazi?
Yes, miss?
Yes. Can you do this next? So we have to convert this in millimeters. We have to write this in millimeters.
Yeah, miss, I'm sorry, but I mistakenly put it, I forgot that I was raising my hand.
So you don't want to answer this?
Yeah, sorry, miss.
Oh, okay. Okay, Vivo. Now, because you're not using your real name, so I won't choose you, okay? You have to use your real names. I'm not going to choose fake names. Mariam. Mariam. I just unmuted. Mariam Wasim. Okay. Okay, I will choose Momina. Okay, Momina. Yes.
Yes.
Momina? Yes. Can you convert this centimeters into millimeters?
Okay.
Okay.
So
First tell me how many millimeters and 1 centimeters? How many millimeters in 1 centimeters, please? Okay, because we have a lot of background. We have a lot of background noise. Umaima, Umaima Anwar, Umama, sorry.
Yes.
Yeah. Okay, Umaima, you're unmuted. Do you want to convert this into millimeters?
Yes.
Yes. Okay. So tell me how many millimeters in 1 centimeters first?
100.
100?
10.
100?
Sorry.
10, right? This is a ruler, right? This is 1 centimeters and there are 10 divisions. Okay, this is 1 centimeter and there are 10 divisions. So 10 millimeters is equal to 1 centimeters. Okay, 10 millimeters is equal to 1 centimeter. So now, so if this is how I do, if 1 centimeters is equal to 10 millimeters, and I will cut this. So then 22.4 centimeters would be, now guide me, Umama, or Umama, guide me. Tell me what to do next.
2 to 4. 2 to 4 will be the answer.
Yeah, so basically we are multiplying 22.4 by 10, right? And so the decimal would jump forward 1 place, and so we will get 224 millimeters, right? Okay, 224 millimeters. Okay, 330 micrometers. Micrometers. How many micrometers in 1 millimeter? Yeah, that's a little tough. Okay, who wants to do? Iman, Asim. Iman, Asim. Hmm? You
Yes,
can do?
miss?
Yes, can you convert this? Micrometers into millimeters?
Micrometers into millimeters?
Yes. Okay. Okay. No? Iman?
No, miss. I didn't join the last class.
Oh, okay. So then why is your hand raised? Please lower down your hands. Okay, Sidra wants to try, so give her a chance. Okay. No, micrometers should be converted into millimeters. Express the following in millimeters. You have to convert this into millimeters. Yeah, that's the thing. See, okay, let's work this out together. Okay, so 10 to the power 6 micrometers is equal to 1 meter. This is what we know, right? Because micro, remember in the last class we did 10 to the power 6 micrometers is equal to 1 meter. And 1000 millimeters is equal to 1 meter. So 1000 millimeters is equal to 1 meter, right? If both of them are equal to 1 meter, that means 10 to the power 6 micrometers is equal to 1000 millimeters, right? Right. So this is how I will do. I don't know if you don't understand, let me know, okay? I'll explain you again. So 10 to the power 6 micrometers is equal to 1000 millimeters. So I'm not using that 1 meter thing here because, okay, so 330 micrometers would be equal to what? I will cross multiply. You know what I do? This is my method. Somebody taught me when I was, one of my teachers taught this method to me. This is called the ratio method. And what we do in this is that we write same units together. We write same units together, one above the other. The unit that you want to find out should be on the right-hand side, right? The unit that you want to find out, the unit that you want your final answer to be in should be on the right-hand side. So I want my final answer in millimeters, right? Because that's what the question is asking. The question is saying that express your answer in millimeters. So that's why I wrote millimeters on the right side, right? So I know that if 10 to the power 6 micrometers is equal to 1 meter and 1000 millimeters is equal to 1 meter, then that means they both are equal to each other, right? Right. So 10 to the power 6 micrometers is equal to 1000 millimeters. Can I say that? Yes, I can. My video got stuck. Okay. So 330 micrometers would be, so I cross multiply. So the answer that would come here would be a product of these two things getting multiplied to each other. And then what is left, you will divide the whole thing by that. 10 to the power 6 micrometers. Okay. So, then this is 330,000. 330,000, right? 330 and then 1,000 divided by 10 to the power 6, which means 6 zeros. So I will open it up so that I can cancel the zeros. Okay, I'm opening it up. I'm not writing 10 to the power 6, but I'm actually writing the 6 zeros down. So there are 4 zeros at the top. I will cancel 4 zeros at the bottom. Okay, so now I am left with 2 zeros. So the decimal is here, right? So the decimal, and there are 2 zeros in the denominator, so the decimal would jump 2 places backwards. And so it became 0.33 millimeters. Did you understand? If there is anybody who did not understand, I can explain this again. I can explain this again. If there's anybody. Urwa, Urwa, I'm unmuting you. Urwa? Oh, sorry.
Yes.
Yes, Urwa, did you understand?
Yes.
You understood?
Yes.
Okay. Okay, so no question?
No.
Okay, good. Okay. Sabiha Azhar?
Yes, teacher.
Sabiha Azhar, did you understand? Or do you have any question?
I have a question.
Yes, please.
Here for when you said like to how do we like convert like the how do we know to that 3 like how do we like know the answer of like this question like
Okay, you did not understand how I worked this question out. Huh? Okay, let me explain this one more time. Okay, let me explain this one more time. Okay, so what I did was that I have to convert this micrometer to millimeters, right? Okay, so from my table that you have to learn this, I know that 10 to the power 6 micrometers is equal to 1 meter and 1000 millimeters is equal to 1 meter. If both of them are equal to 1 meter, that means they both of them are equal to each other, right? They are both equal to each other. So that's what I used here. So I know that 10 to the power 6 micrometers is equal to 1000 millimeters. Okay, and then I use this ratio method. Okay, now ratio method is very commonly used in unit conversions. So you write what you already know. So 10 to the power 6 micrometers is equal to 1000 meters, and the unit that you want your final answer in should be on the right side. On the right side, okay? So I have to convert 330 micrometers into millimeters. So what I did, how do you get this? What comes here is decided by the product. You cross multiply the numbers, and then you divide by what is left. So 1000 millimeters, I multiplied by 330 micrometers divided by 10 to the power 6 micrometer. Now, how do I calculate this? I opened up all the numbers, okay? So this is 1000, this is 330. So 330,000. So I wrote down 330,000 divided by 10 to the power 6. 10 to the power 6. So 10 to the power 6 means 6 zeros, okay? And there were 4 zeros on both the sides. On both the sides, there were 4 zeros. So I can easily cancel 4 zeros at the top as well as at the bottom, right? And so what I am left behind with is 33 divided by 100. And that's easy, right? Because there are 2 zeros in the denominator, the decimal place jumps back through 2 places backwards. So I get 0.33 millimeters, okay? Now let's move on to the next question, which is to convert 5.6 into 10 to the power 4 nanometers in millimeters. Now, by the way, I got these questions from your book, the end of chapter book, or maybe further questions. I can't remember, but okay. So now we have to convert 5.6 into 10 to the power 4 nanometers. Who wants to do this? And people who don't want to do this, please lower your hands. You have to convert this into millimeters. You have to convert this into millimeters. Okay, I will also tell you, hold this camera. 10 to the power 9 nanometers is equal to 1 meter, and 1000 millimeters is equal to 1 meter. So I'm giving you a hint. Okay, so that means 10 to the power 9 nanometers is equal to 1000 millimeters. So now who will tell me what to do next? Let them have a chance, and then I will ask you. Rayan Musharraf. Yes, Rayan?
Yes.
Okay, tell me how to, what should be the next step?
We will write. We will
Yes.
5.6
Very good.
nanometers
Into 10 to the power 4 nanometers would be equal to,
would be equal to, we will do the cross multiplication.
yeah, I'm sorry, my video stopped. Go and tell Baba that my video has stopped. Yeah, it's back. It's okay. Okay, so 5.6 into 10 to the power 4 multiplied by 1000, right? 5.6 into 10 to the power 4 into 1000, and then divided by 10 to the power 9, right? So now how will I go about doing this?
It will be 56,000.
56,000, and how did you figure that out?
No, not 56,000. I thought it was only 10.
Okay, so let's open this up. Okay, let's open this up. So okay, Sidra wants to open it up. Okay, you go ahead, do it. Okay, so 5.6 into 10 to the power 4 into 1000. So yes, so the decimal place would jump forward 4 places. Would jump forward 4 places. 1, 2, 3, 4. So yeah, so this makes this 56,000. 3 more zeros. 1000 multiplied by 1000. Again, because this 1000 is still there, right? Right. Okay. Now, yeah. So divided by 10 to the power 9. I'll open up 10 to the power 9. First, right? Show step by step. Then another step. Okay. Now, what is equal to sign here? Right. 3, 4. Okay. 10 to the power 9. Now I'll open up. Yeah, okay, open up. So 9 zeros. Okay, so now how many zeros will you cancel? 1, 2, 3. Okay, okay, and then 3 here, 3 here. So what are you left behind?
1000.
Yeah, so then, so now this is over 1000. So 1000 has 3 zeros. So again, decimal would jump 3 places backwards. Do it here, show it here. Yeah, okay. Yeah, write down. Okay, you should have shown it here. So 56 divided by 1000. So 1 jump, 2 jump, 3 jump. So 0 here. So 0.056. Good job, Sidra. Good job. 0.056 millimeters. Okay? Okay. Yeah, this was one long working. Okay. Now, we have done these. Now, express the following in seconds. 5,000 milliseconds. How will you convert 5,000 milliseconds into seconds? 5,000 milliseconds. Who wants to do that? Who wants to do this question? Muhammad Abdul Ahad. Yes, Muhammad Abdul Ahad. Can you convert this 5,000 milliseconds into seconds?
5,000 milliseconds.
So
The
you put,
answer is
no. Don't give me the answer. Tell me step by step. How many milliseconds in 1 second? First of all,
they are 100.
100. Are you sure? Milli, right? Milli. The prefix milli means, what does milli mean? We did in the last class.
Teacher, I
No.
was not in the last class. But
Okay,
I know that
milli.
there are 100 numbers in mini.
No, 1,000. Milli means, yeah, milli means 1,000. Okay, milli means 1,000. So 1,000 milliseconds is equal to 1 second.
1 second. So there are 5 seconds in 5,000 milliseconds.
So 5,000 milliseconds will have,
5 seconds.
right, 5,000 milliseconds into 1 second divided by 1,000 milliseconds. So 3 zeros and 3 zeros, so 5 seconds.
Teacher,
Right? Yes.
could you undisable the chat option because
Can you enable the chat? Yeah, we will. Yeah, we will, inshallah, very soon. Because of some troublemakers, because of some intruders, we had to disable the chat for some time. Okay? Yeah, inshallah, it will soon be enabled. Don't worry. Okay, now last question. Last question. 4 into 10 to the power 6 microseconds should be converted into seconds. Who's gonna do this? Who's gonna do this? Zainab Ihsan. Yes, Zainab Ihsan. Yes.
I don't really want to answer. I just have a question.
Okay.
I don't really get how we're supposed to do microseconds to seconds.
You did not understand the millisecond into second question?
No, teacher.
Okay, so okay. There are 1,000 milliseconds in 1 second, right? So how many seconds in 5,000 milliseconds? Okay, so I am using my ratio method, which I just taught you. In that, in unit conversions, on right hand side should have the unit that you want your final answer to be in. So you want your final answer in seconds, right? Because that's what the question is saying. Express the following in seconds. So I want the answer in seconds. So seconds will be written on the right side. Okay. And so I will cross multiply 5,000 milliseconds into 1 second, and I divide it by 1,000 milliseconds. Right? Or you can say that if I have 1,000 milliseconds is 1 second, So 5,000 will be 5 of them, right? 5,000 would mean 5 of them, 5,000 milliseconds. And each one of them is equal to 1 second. Each one of them is equal to 1 second. So total 5 seconds, you know, in simple words. Did you understand? Okay. Now let's move on to this next question. 4 into 10 to the power 6 microseconds is equal to how many seconds? Who wants to answer this question? Anas. Yes, Anas?
Yes, ma'am.
Yes, 4 into 10 to the power 6 microseconds is equal to how many seconds? So let me give you a hint. 10 to the power 6 microseconds is equal to 1 second. So 10 to the power 6 microseconds is equal to 1 second.
If I have to multiply, first I have to multiply 10 to the power of 6 with 4, and then I have to take out the seconds, yes?
We have to multiply?
Yes.
Or we have, yeah, so we will cross multiply the numbers which are at cross from each other, right? And what is left, we will divide it, we will divide the thing by that, 10 to the power 6 microseconds. So 10 to the power 6, 10 to the power 6 get cancelled. And so we are left with 4 seconds. 4 seconds. Yeah. Okay. Okay. So with this, we have completed all the questions. Now let's start the next chapter of energy. And now because most of the time was taken by these questions, so only 15 minutes are left. So I will just really quick introduce the chapter to you, and we can do this chapter in detail next time, inshallah. Okay. So what is energy? What is energy? In simple words, energy is the ability to do work or cause a change. Okay, energy is the ability to do work or cause a change. Now, what do I mean by change? And what do I mean by work? Work, okay, so let's talk about change first. Like, for example, if I want to crush a piece of paper, if, for example, I want to crush a piece of paper, what am I doing? I have changed its shape, right? I have changed its shape, and I can change its position. You know, if it's kept here, I can keep it here. So that's a change. Okay, I can change its shape. I can change its color by painting it, or I can change its color by burning it, right? So all of these changes will require energy. So no change takes place on its own. Whatever change you see around yourself is a result of some energy. Okay, so and this is how energy is defined. Energy is the ability to do work or cause a change. Now that change can be even change in temperature. Okay, change in energy can change an object's motion. Okay, if something is moving fast, I slow it down. That's a change, and that will also require energy. If something is moving slow and I want to fasten it up, I have to apply energy, right? All these are types of changes that will require energy. Now, there are different types of energy. Okay, the two main types that we will deal with are kinetic and potential energy, right? But there are other types of energies as well. But kinetic and potential are the two main types, and then we have subtypes. In kinetic energy, remember, kinetic energy is the energy of motion, energy of movement. Now that movement can be of the whole object, meaning the whole object is moving, like a car, the whole of car moves, or when we are walking, our whole body moves, or it can be just vibration of particles. It can be just vibration of particles, like when the temperature of an object increases. Now, when the temperature of the object increases, the particles, the small particles that make that object, they start vibrating with a lot of energy, right? So that is also kinetic energy, but the object itself stays in its position, right? But that is a different type of kinetic energy that increases its temperature. Now, electrical energy is the energy due to moving electrons. Now, I hope you remember the structure of atom. We did the structure of atom, and I introduced you to the electrons, or maybe you already knew electrons from grade 5. So electrical energy is due to the movement of those electrons, okay? Sound energy is due to the vibration of particles back and forth. Remember, sound energy is produced due to the vibration of particles back and forth. So you can see that in all these cases, the particles are moving. In electrical energy, electrons are moving. In sound energy, particles are moving. Can be atoms, can be molecules, whatever. Thermal energy is again due to the vibration of particles, is due to the jiggling of the molecules or atoms that the substance is made up of. So these are a few examples of kinetic energy. Then we have potential energy. Now, what is potential energy? Potential energy is a stored energy or energy due to position. Position of either the whole object or the particles that are making the object, okay? Examples of potential energy are chemical potential energy, the energy which is stored within the molecules and in the bonds of the molecules. And I know many of you might not understand this, but I'm just introducing it and I will explain you in detail. So right now I'm just introducing you to the names of the different types of energy. Then we will talk in detail about each one of them. Then we have gravitational potential energy. Now, gravitational potential energy is due to the position of an object above the ground or height of an object above the ground, right? Gravitational. So force of gravity is involved in this. It's actually the force of gravity that does the job, okay? Magnetism. Magnetism is the energy which is due to the repulsion between like poles of magnets and attraction between the unlike poles of magnets. That repulsion causes movement, right? That attraction causes movement. So that means there is some work going on. There is some change. So that change is brought about by magnetic energy. It's also called magnetic energy. Then we have nuclear energy. Nuclear energy, now I'm just introducing you real superficially. Nuclear energy is the energy which is keeping the nucleus of an atom intact, which keeps the nucleus of an atom intact, meaning it keeps the protons together within the nucleus. Remember, the nucleus of an atom is made up of protons and neutrons. So because all the protons are positively charged, they tend to repel each other. But this nuclear energy is responsible for keeping them together in that small nucleus despite their repulsion, despite the fact that they are repelling each other. Then we have elastic potential energy. Now, this elastic potential energy is possessed by substances which are elastic, such as a spring or rubber bands, elastic bands, okay? They tend to recoil into their original shape after they are being pulled or stretched or even compressed. So when we are pulling or when we are compressing them, we are storing energy in them, and that energy does the job of recoiling. So that is called elastic potential energy. So when we are compressing them or pulling them, we are storing elastic potential energy. We will talk in detail about all of these. So this is just an introduction. Okay, now energy can be measured. It is a measurable quantity and its units can be joules or kilojoules or can be calories or kilocalories. But in IGCSE, we use joules and kilojoules, okay? Now, I will also introduce you to the law of conservation of energy. Conservation means to save. It means to save, okay? What it says is that energy is neither created nor destroyed, but it is only transferred from one form to another. So energy can never be created or destroyed. It is only transferred from one form to the other. So ever since this universe has come into existence, the amount of energy is the same, is constant. It is only changing from one form to the other, okay? So some forms are more usable, more useful to us, and others we cannot use. We don't know how to use them. And this is usually the thermal energy, the heat. Thermal energy thermal energy is also referred to as heat. Okay, so remember, all these types of energies that I have talked about, all of these types of energies can be converted into thermal energy. Can be converted into thermal energy. And whenever there is a transfer of energy from one form to another, thermal energy is always produced. All the energies can be converted into thermal energy. And thermal energy is a useless form of energy. The useless form of energy is thermal energy that only makes objects hot, but we cannot use it. We cannot use it, okay? That's why machineries get hot. You know, machines get hot, the laptop gets hot, the cell phone gets hot when we are using it. Why? Because there is energy conversion going on, and whenever there's an energy conversion, thermal energy is produced, which is heat, which makes the objects hot, and which means that some energy is wasted in the form of heat. Right. So we try to minimize this wastage. We try to minimize. So a machinery that gets hot less is more efficient as compared to a machinery that gets hot quick. Right. Okay. So, okay, now let's talk about each type of energy in detail. Okay. I want to talk about the gravitational potential energy first, and I will share my screen. Now, gravitational potential energy is due to the position of that substance above the ground, okay, the height, which is called the height, okay. The higher, the more the height of a substance above the ground, the more the potential energy, okay. So as you can see in this first picture, the bicyclist, which is at the top of the hill, has the most potential energy. Why? Because now potential energy is energy stored. Stored meaning it is stored, it isn't doing work yet, but it can do work. It has the ability to do work in the future. So it can be used, okay? And it is due to the position of either the object or position of the particles. Like in case of elastic potential energy, it is the position of the particles. Like in case of chemical potential energy, that's due to the position of the particles, right? But in case of gravitational potential energy, it is the position of the whole object, height above the ground. So this bicyclist at the top of the hill has the most potential energy because, first of all, he is at the maximum height above the ground. That's why he has maximum potential energy. And kinetic energy was the energy of movement, motion. So as you can see, when he is climbing up, he's actually moving. So as his height above the ground increases, the potential energy increases. But as you can see that when he reaches up, his speed must be decreasing. As he's going up, his speed is decreasing. Speed decreasing meaning motion is decreasing, right? So motion is decreasing meaning kinetic energy is decreasing, but potential energy is increasing. Why? Because the height above the ground is increasing. Yes, yeah, and when he's coming down, you can feel that the cycle gets the fastest when he's reaching the bottom of the hill. Why? Because yeah, the kinetic energy is maximum just near the bottom. Just near the bottom, it is the maximum. Why? Because all the potential energy has been converted into kinetic energy. Now, potential energy is decreasing. Why? Because the height has decreased. Yeah, the height has decreased. Now, this is another example of potential and kinetic energy. Now, I told you potential energy is a stored energy due to the position of the particles or the object. Now, in this inflated balloon, the balloon which is all blown up, it's inflated. There are particles, air particles inside bouncing against the this plastic balloon. And so they are crammed up in a small space. They are waiting to be released out. So they have energy that they want to release. So this is potential energy. So it's stored, it's not being used as yet, but it's there. And as soon as it gets a way out, I mean, you open the knot and you deflate or you pop it, and it gets a way out, all the air molecules will burst out, and that will cause the balloon to move. And that is kinetic energy. That's an example of kinetic energy because the balloon is moving, right? Right. When the balloon gets burst, it moves really random in random directions before falling to the ground. So that's kinetic energy. This is another example of potential energy getting converted into kinetic energy. Now again, this boy is holding a ball above the ground, and so again the ball is at a particular height from the ground, and this height is giving it the gravitational potential energy. Now, as I told you, potential energy has types. We have chemical potential energy, nuclear potential energy, and then gravitational potential energy. Now, gravitational potential energy is due to the height above the ground, and it is the force of gravity which is doing this job of the motion of the ball. Now, this is another example, swing or pendulum, swing or pendulum. Now, when the swing is at its highest height, okay, on the right-hand side, where the girl is at the highest height above the ground, because of the highest height, the potential energy is maximum. But if you have been on a swing, and I'm sure all of you must have been on a swing, you must have observed that when your swing reaches the highest point momentarily, for like 2 to 3 seconds, the swing stops before you move back, before you fall back, right? It stops for like 1 or 2 seconds before it falls back. And it is the fastest, the swing is the fastest when it is at the smallest height above the ground, when it is at the lowest point of its journey, right? At the second position, which is shown in this picture, in the second position, the left-hand side, the girl's picture, which is exactly vertical, hanging below the rod, right? So the potential energy is the maximum when the girl is at a maximum height above the ground, and the kinetic energy is maximum when the girl is at the lowest point above the ground, right? And remember, potential and kinetic energy together are called mechanical energy. Mechanical energy. Mechanical energy is the energy to do work, because it is the combination of potential and kinetic energy which enable us to do work. Okay? Burning candle is no, it has chemical potential energy. Okay, let's try to answer this question. The diagram below represents a bicyclist at the top of a hill with 4 points labeled W, X, Y, and Z. Assume that the bicyclist does not apply the brakes as he rides down the hill. At which point will the bicyclist's kinetic energy be closest to 0? Okay, I'll repeat the question. At which point will the bicyclist's kinetic energy be closest to 0? Right, now let me see who can answer this question. Okay, Muhammad on Ali. Yes, Muhammad on Ali.
Yes.
Sorry. Yes, now tell me.
Yes, ma'am.
Yes,
Ma'am,
tell me.
the answer will be Z.
Z? Kinetic energy will be closest to 0 at which point? No, not Z. Okay, let me see. Ahmed Atif.
Yes, teacher.
Ahmed Atif? Yes, tell me at which point will the kinetic energy be closest to 0?
At point X.
Why? See, I just told you that kinetic energy is the maximum at the bottom because it is due to motion. Kinetic energy is the energy of motion, and potential energy is maximum as the height above the ground increases, right? Because the potential energy has to do with height, remember. So, and potential energy and kinetic energy cannot be maximum at the same time. If one is more, the other is less. Okay, if one increases, the other decreases. Remember this. So if you know that at W, the potential energy will be the maximum, right? Now let me ask from Urwa. Urwa?
Yes, ma'am.
Yes. Now you tell me at which point the kinetic energy be closest to 0.
W.
Why?
Because it is because on the top and it is the
Yes, your answer is
potential energy is inside.
yes, at point W, the potential energy is maximum because the height is maximum above the ground. And when the potential energy is maximum, kinetic energy will be minimum. Because they are opposite to each other. Potential energy and kinetic energy cannot be maximum at the same time, right? If one is maximum, the other is minimum. Okay, we'll talk about this more in detail in next class. So I will end the class at this point, okay? Okay, assalamu alaikum wa rahmatullahi wa barakatuh. No, there's no time left for questions. Okay.